In this video, we are going to see priority queue. Priority queue is a queue, but it does not follow the usual queue order FIFO first in first out or LIFO last in first out. Instead, it has its own logic to manage the insertion and removal order. In priority queue, each element has a priority, as the name suggests. So when we add a new element to the queue, it reorganizes itself based on the newly added item's priority. And when we remove an element from the queue, the item that gets removed is decided based on the item's priority. So it's all about priority. Now, how does it decide the priority? It comes back to the comparable and comparator. When we implement the comparable, the compare to method will decide the priority of that element. Alright, if we don't implement the comparable, then we'll have to provide a comparator that will be used by the priority queue to define or to decide an element's priority. So when we are adding a new element, priority queue will use the comparable or comparator to compare this element with existing elements, and it will reorganize the whole structure based on that comparison. So when we remove the element, the item that will be removed will have either low or high priority based on how we define the compare to method. So let's see a quick demo. Here we have a class patient. So let's see, we are creating an application to maintain the hospital queue or the doctor's queue. So this class represents a patient. Each patient has a name and a criticality, how critical that patient is. And then we have the toString method to see a nice output on the console. Here we are creating a new priority queue. So we use the class priority queue. We provide the data type that this priority queue will store elements of type patient. And then we are using the default constructor. That means we are thinking about the natural ordering, which means the comparable interface in Java. Okay. So how do we add elements to this priority queue? We do eq.offer. We use offer method of the queue, and then we add a new patient. So we say the name of this patient is P1 and criticality is, for example, 3. So in our example, the priority is going to be 1 to 5. Okay. So 1 is going to be the higher priority and 5 is going to be the lowest priority. So we added one patient to the queue with criticality 3. That means the medium criticality. And if we run this program, then we see the same exception that we have seen, that this cannot be cast to comparable. That means we have to implement the comparable interface. Otherwise, priority queue is not able to compare the elements. And because we have not provided a comparator, so that means it is using the natural ordering. So let's implement the comparable. Then we have to implement the method compare to, and we will simply compare the criticality of two patients. All right. This time, if we run the program, it would work just fine. Okay, we don't see any error. That's fine. So we added first patient with criticality 3. Now let's see another patient comes and he is critical than P1. So his name is P2 and his criticality is 2. All right. But then another patient comes who is more critical than P1 and P2. His criticality is 1. So we see every time when we add a new patient, the queue will reorganize itself based on this criticality. So it will use the compare to method of the patient class to compare two patients, and based on the comparison, it will identify which patient has more priority, and that will be at the front of the queue, so that when we remove the element from the queue, the patient with higher priority will be removed, and so that we can process that element. All right. Having said this, if we now remove an element from this queue, to do that, I will simply say poll, so we would see the patient with higher priority, which is P3 with criticality 1. So you see, although we can add elements in any order that we like, but the queue will reorganize itself based on the comparison based on the criticality. So if I change the order like this and run the program again, even then I will get P3. And if I poll again, so the next element that has more priority is P2. So we would see P2 here. So priority queue is all about defining the priorities of elements. To do that, it uses comparable or comparator based on the compare to method. It compares two elements and decides the priority. And when we remove the element from the priority queue, the element with more priority or with higher priority gets removed from the queue. That is the whole purpose of priority queue. So in situations like maintaining a hospital queue or maintaining a queue of jobs, we can use priority queue so that, let's say, a job with higher priority will get removed first